Okay, our first exercise is 16. When you sneeze, the air in your lungs accelerates from the rest to 150 km per hour in approximately 0.5 seconds. What is the acceleration of the air in meter per second squared? Okay, let's solve. Let's write given. First of all, we have final velocity. It's equal to 150 km per hour. Yeah, and the final time is 0.5 second, and we need to find acceleration. It's acceleration in meter per second squared. Okay, and let's write formula for this equation. We have this formula: acceleration equal to delta v divided by delta t. Yeah, and delta v is equal to final velocity minus initial velocity, and the delta time it's final time minus final velocity, well, initial time. Yeah, okay. And we need to change this kilometer per hour to meter per second. Let's write with final velocity equal to 150 multiplied 1000 divide 1 and multiply this 1. It's equal to 41.7 seconds. Yeah, and let's write solution. Acceleration equal to final velocity is 1 and there is not second, meter per second. Yeah, okay. 41.7 minus 0 initial. Our initial velocity is 0 because it's not given. Yeah, and final time is 0.5 minus initial time. It's also 0 because it's also not given. And we solve this. And it's 43 meter per second squared. Yeah, it's answer, and it's our first equation. And our second equation is 17, and a speed skater moving to the left across frictionless ice at 8 meters per second hits a 5 meter wide patch of rough ice. She slows steadily, then continues on at 6 meters per second. What is her acceleration on the rough ice? Yeah. Okay, let's solve. First of all, we need to write given for easy to solve. We have initial velocity, it's 8 meters per second, and the final velocity is 6 meters per second, and displacement 5 meters. And we need to find acceleration in meter per second squared. Okay, let's write formula. We have this formula with the final velocity squared equal to initial velocity squared plus 2 acceleration delta displacement. Yeah, and we need to find acceleration, and we change these places, and we write acceleration equal to v final squared minus v initial squared divided by 2 delta s. Yeah. Okay, and we just place these numbers to this formula. Yeah, let's write solution. Okay, a equal to v final, it's 6 squared minus 8 squared of initial, and 2 multiply 5. Yeah, and there we have 36 minus 68 64, and 10. Yeah, and there is answer is acceleration we found is 2.8 meter per second squared. It's our answer. It's second equation. Yeah, 17. Okay, and the third equation is 18. Yeah, a Porsche challenges 100 to 400 meter race because the Porsche's acceleration of 3.5 meter per second squared is larger than the Honda's 3 meter per second squared. The Honda gets a 1 second head start. Who wins by how many seconds? Okay. Okay, let's solve. Okay, first of all, let's write given. Yeah, we have distance 400 meter. Yeah, and the Porsche's acceleration is 3.5 meter per second, and the Honda's acceleration is 3 meter per second. Yeah. Okay. First, and we need to find time. Yeah. Because we need to find who wins. Yeah. In seconds. Okay. Let's solve. Let's write formula first of all. Okay. Formula. Okay. Seconds. Okay. X. We have a formula like the distance delta v plus acceleration delta t squared. We have this formula, and our v initial is 0 because it's not given. Yeah, and we change this formula for this to this. Yeah, and we need to find time, and we write delta t second. Yeah. Okay, and let's solve. Yeah, first of all, solution. First of all, we find Porsche's time. Yeah, delta t time s 100, and Porsche's acceleration is 3.5, and there is 805, and there is delta t is 15.1 second. Yeah, it's Porsche's, and second Honda's time. Delta t it's 203. Yeah, its acceleration is 3, and delta 3 it's equal to 16.3 second delta t, and we minus 1 because it starts in 1 second heat start there, and 15.3 second, and we see that Porsche wins because its time is 15.1 second. Okay, this is our third equation. Okay, and our last question is 19. A car starts from rest at the stop sign. It accelerates at 4 meters per second squared for 6 seconds, goes for 2 seconds, and then slows down at a rate of 3 meters per second squared for the next stop sign. How far apart are the stop signs? Okay. Let's solve this. 19, yeah. First of all, we need to write given our initial velocity is 0 because it starts rest. Acceleration is 4 meters per second, yeah, and our time is 6 seconds, yeah. First of all, we need to find a distance traveled, yeah, and wow, we have this formula as one vt plus 1.1 at squared, yeah, and our initial velocity is 0, and we write that change the formula for that to that, yeah, and we write acceleration is 4 and the time is 6. There we find that 2 and 2 72 meters, yeah. Okay, and we need to find costing part. Okay, and first of all we need to find costing velocity. We write this formula initial plus 80, that it's 0, we know it, and equal to 80, and v equal to 4 acceleration, and the time is 6, and costing velocity is 20 meters per second, yeah, and we need to find this costing distance here. We know that costing time is 2 meters, 2 seconds, yeah, and 2 seconds, and we find for this formula second to velocity divided by time. Our constant velocity is 24 and the time is 2, and the second distance is 48 meter. Yeah, okay. And we find, and the third is deceleration because it's down. Yeah, okay. And the first we need to write a formula. It's v2 minus v constant and v initial to equal to 2 acceleration distance, and we need to find distance, and we changes places. 3 is v initial and yeah, and okay, and there is our 0 minus 24, and there is 6. Yeah, you know it, and there is 6 24 and 6 is 4. There is meter. Yeah. It's, and with total distance we write total distance, it's x1 plus yeah, and we know that distance that 72 first plus 48 plus 96. Yeah, and the final we found that 116 meter. Its answer is total distance equal to 100 meter. Yeah, and it's last question.